Hello, welcome back to our channel, The Classroom. Now I'm back with chemistry as said, and I'm going to start with the first chapter of chemistry of class 8, that is the chapter matter. Yes, we have similarity of the chapter of physics and chemistry, that is the first chapter, that is matter. Here also same wise we are going to study about matter. Yes, there will be some few more added points here since it is chemistry. You know it will be dealing more about molecules and atoms. Okay, so let's get started. You can easily understand the difference. Okay, now as from the first, that is from physics also, you have seen that I have drawn these diagrams of the different states of matter on the board. So have I done here also. Now first, considering what is matter. The chapter insists matter. So what is matter? As discussed earlier in case of physics, the first session obviously, there also I have said that I have whatever I have touched, I can feel, or whatever we can see and then we can feel it. Okay, that itself is matter. This board, the duster, the chalk, everything that we are using, okay, everything is matter. The things which we can hold, which we can have feelings, we can sense it, everything falls under matter. So same definition here also you can add, that is matter is something that occupies space and has mass and can be perceived by our senses. Okay, so same definition as in physics we are using, same definition here also in chemistry. Next, coming to the point that as we have already known that matter is composed of molecules. Now molecules are again composed or consisted of atoms. Those are the very tiny particles. Now a single atom never exists, okay, freely exists in the nature. It is always in the combined nature that it exists, because it forms, that is it combines with other molecules to form substances, or maybe undergoes any chemical reactions to form different elements or compounds and so on. Okay, so coming to the molecules, it is one of the part of an compound. Molecule is a smallest unit of an compound, okay, whereas an atom is the smallest unit of an element. Okay, now this atom, if you say, it is the smallest indivisible particle which cannot be broken down. Okay, it's the smallest indivisible particle that undergoes a chemical reaction. It is not the molecules that is going a chemical reaction. We have chemical reaction. Suppose hydrogen is getting mixed with oxygen, okay, to form water at a particular obviously condition. So whenever this water is formed, this is a molecule. Okay, now atoms are getting added up in different conditions to form a molecule. So whenever it is about the chemical reactions, it is nothing but the atoms which goes for the chemical reactions. So that is why it is said that is the smallest indestructible part of the molecule or of the element. I hope I'm clear with this point. That is why once again I'll repeat the definition of atom. It is the smallest indivisible part of an element which undergoes a chemical reaction. If asked, you can give this definition. It's just the perfect definition for atom. Next, coming to about the kinetic theory of matter. Before I start with the kinetic theory of matter, I will be stating the same characteristics of matter which we have already done in physics. The first one is of its very small size. I have already told you that it is of the size of 10 to the power minus 10 meter. Okay, that is very negligible and cannot be seen with the eyes, with the naked eyes. You need a microscope to see that. Anyway, the second one which we know is the intermolecular space of the molecules. Okay, that is a space which exists between the molecules. Here in solids it is almost negligible. In liquids it is still there, and it is much more in case of gas. Okay, next coming to the intermolecular force of attraction. Just because of closeness of the molecules, okay, the force of attraction is maximum in case of solids. It is less in case of liquid and much more least in case of gas. You can either say it is negligible in case of gas, the force of attraction, just because the molecules are very far away from each other. Okay, and lastly comes the vibration, that is just because the kinetic energy. As you know, the molecules are always in their kinetic motion. Okay, that is because they have a particular energy which makes them to move in their own mean positions. Now, whenever they get particular energy to leave their attractions, it changes to liquid, and so on for gases. Kinetic energy is least in case of solids, then it grows for that in case of liquid, and it is maximum in case of gases. That is why they can move so randomly. Okay, this is just the one which we have discussed in physics. Next, coming up with the kinetic theory of matter. Now, the first point, that is kinetic theory, the first point, or rather we can say that the existence of the three states of matter along with their molecules, everything consists of the kinetic theory of matter. Okay, all the things we are going to discuss within the kinetic theory of matter. Now, starting with the first point states that these particles are very tiny, are very small, okay, as we have discussed in the characteristics. Second one, it is said that a particular element will always have the same type of atoms or the same type of molecules. A particular element will be having the same type of these tiny particles. Like for example, atoms of hydrogen will be similar to each other. If I say for different other elements like nitrogen, the atoms of the nitrogen will be very different from that of the hydrogen atoms. So all the atoms are very different from each other. But for a particular element, atoms will be all alike. Okay? Like suppose one small example, like in your family, suppose you have your father, mother, sister, brother and you. So there are 5 members in your family, right? So 5 of you are having almost, if I'm not wrong, all have the same title, right? So same wise, these elements have the same type of atoms. Okay? Next, coming to the third point, that is they have intermolecular spaces. The space between the molecules of each of these matters, solid, liquid and gas, are known as intermolecular space. Now it depends on the different states of matter. For solids, it is that there is no space in between the molecules. In case of liquid, there is much more space than the solids, and for gases, there is full availability of spaces. The molecules are very wide apart from each other. Next, fourth point. We come to the fourth point, which states that these molecules have one type of attraction in between them, which are known as intermolecular force of attraction. Intermolecular force of attraction states that these solids, which you can see, these are the particles, okay, tiny particles, which are known as the molecules, or you can say the atoms. These particles, these molecules are so closely packed that they have a strong bond acting between them. They have a strong bond acting between them. As soon as these particles or these molecules get separated from each other, like in case of liquids, these attraction also loosens up. Okay? And so for gases, it is you can say it becomes very less or maybe negligible, because you can easily see there is lot of space in between the molecules of the gases. As it is very visible just because of the molecular distance, okay, the space is so large that the force of attraction also get loosened up. Therefore, the force of attraction in case of gases is very, very less. Okay, almost you can say negligible. Now, next coming to the fifth point, that is the kinetic energy. Existence of the kinetic energy. This energy is one because every molecule have some energy in it. So for that reason, they are always vibrating in their mean position. Now, while vibrating in their mean position, they always release out some energy, or maybe transfer of energy takes place. Okay? Next, there is liquid. In liquid, what happens is, the molecules might get like collided with each other, with wherever in a container it is stored, it will be hitting the walls and so on. So that comes for your liquid. Kinetic energy is more in the case of liquid than solids, and it becomes maximum in case of gases, because as you can see, they are very wide apart. Whenever they clash with each other, there is a lot amount of exchange of energy, and so on, they move more vigorously. Because there is an exchange of energy, energy increases more and they move on more rapidly than ever. So that is, kinetic energy is maximum in case of gas. So this was what was kinetic theory of matter. Now, next, as we know that states of matter, we have three parts: solid, liquid and gas, right? So next comes our one small thing that I have forgot, or you just can say I have missed out while saying, that is while telling you about this motion, that the zigzag motion which liquids or gases follow, there was a small experiment done. This experiment was done by Robert Brown. Robert Brown had taken a beaker of water or a liquid, and he has put pollen grains into that water. So when he had put the pollen grains over there, he had observed that the pollen grains were moving very rapidly in the liquid, very much, okay? It was just moving in a zigzag way, and then like colliding with the walls, and then again moving back. It was a very to and fro motion, okay? Now, after this, as he observed, he felt that why is it happening like this? As again we can say, suppose, I'll just explain you with a small example. Suppose this is the liquid, okay? This is a liquid that I have taken. Now, in this, we are taking the pollen grains. This is the pollen grains. Now, pollen grains are very small particles. It is coming within the particles of the, that is the molecules of the water, right? These pollen grains are moving around or moving in between the molecules of the water. They are colliding with the molecules of the water. They are colliding with the molecules of the with the wall, and so on. They are colliding with each other and so on, right? So just because of this reason, a huge amount of energy inflow was acting between them, between the particles, between the particle and the container, the walls of the container, between the water particles and the pollen grains. So there was a huge amount of energy that was being exchanged between them. As possible, this particular zigzag motion was named as Brownian motion after his name. As he carried the title Brown, so the motion, this movement, particular movement, this zigzag movement, okay, so you can see that which way it is going. It is not having any random motion in a particular direction. Any way, in any direction it is moving. So this movement was known as Brownian motion, okay. So this is another term which I had missed out. Now it's over. Now next, coming to the change of the state. Now change of the state, if you say, we know what are the changes, right? The first one to the last one we will be studying. Before that, let me draw the diagram. Now I have taken the diagram of solid, liquid and gas and their changes. Now, the first one, I am going from solid to liquid, that is melting. What is melting? The change of the state from the solid state to the liquid state is called melting. Now, there is one more term that is used, that is melting point. Now, what is melting point? Without, at constant temperature, that is without a change of temperature, when the solid changes to liquid state, okay, or you can say the change of state from solid to liquid at a particular temperature or at a constant temperature is called melting point. Okay, same thing for from liquid to solid. We have to say that when liquid changes to solid, okay, when liquid changes to solid at a particular temperature is called freezing point, or also you can say when liquid changes to solid is called freezing. Melting point, freezing point. Okay, same for your liquid changes to gas is called boiling. When the change of state takes place from liquid to gaseous form or the vapor form, it is known as boiling. And what is the boiling point? At a particular temperature or at a constant temperature, when liquid changes to gaseous state is called the boiling point. Okay, same for from gas to liquid. When gas changes to liquid state is called condensation, as well as when gas changes to liquid at a particular temperature or at a constant temperature is called condensation. Okay, what is sublimation? Sublimation, please listen to this very carefully. Sublimation, when solid changes to gaseous state without changing to liquid state in between. We know that solid first changes to liquid, then liquid changes to gaseous form. But here there will not be any intermediate state. From solid directly it will change to gaseous form. Okay, without this point is very vital. You have to mention in your definition. When solid changes to gaseous form directly without changing to liquid state is called sublimation. Same thing when gas changes to solid state without converting to liquid state is called deposition. This 2 to 3 words, that is without changing to liquid state, is very important because there can be a question mark whenever you are writing any definition. Will it change to liquid state? No, it's never going to change to liquid state because it's a direct conversion. Okay, so here for this, you know, solid to liquid, that is a ice changes to water, water changes to gaseous form or the vapor form. Okay, so these examples, you know, for these, what are the examples? Examples, camphor, right? It is one which remains solid and then suddenly it goes off. There is only the gaseous form. Naphthalene. Okay, this is another one. So these are the examples of, then another one I forgot to mention, that is NH4Cl, dry ice. All these are examples of sublimation. Okay, all these are examples of sublimation. Next, I want to come to another point that I would like to mention, that why is there a change of these states taking place? Why does it happen? The reason is that, suppose solid, you know how the particles are. The molecules are very closely packed. Now if an energy or heat, okay, is provided to this particular these molecules of solid, it will gain energy. Whatever energy it was having, that energy will increase because of the intake of the extra energy from outside. Due to this, these molecules will start randomly moving very fast. Okay, due to that, what will happen? It will move much more further from each other, far from each other. As soon as it starts moving far from each other, it tries to break the bonds that was in between them, in between the molecules. Now as it breaks the bond, its change takes place. But yes, to be very frank, there is no change in the temperature. It is at a particular temperature that happens. It is only the energy, or just because of the energy, that these change of state are taking place. Similarly again for liquid, again same thing. As liquid is gaining, these particles are gaining energy again, maybe with the collision or maybe with the different intake, that is intake of the energy from an outside source. These molecules randomly move much more faster than it was doing before, and again it breaks all the force of attraction or the bonds and it goes far off. It changes to gaseous form. So this is how the change of state takes place. And next, coming to one point, that is the last point that I want to discuss, that is that these changes are not the permanent ones. Okay, these are reversible ones. As you can see, it's melting, then again freezing, here boiling, then again condensation. Okay, now I've almost come to the last part. Just one thing I want to say, I have written here boiling. Okay, what if I am writing here? What if I am writing here evaporation? Right? I can use the term evaporation. What is wrong in that? Nothing wrong. There is a small difference that I would like to share. That is, there is a difference between boiling and evaporation. In boiling, you need to provide an extra energy. That is, an outside source is required to put a energy to that particular liquid. Okay? So that is known as boiling. Whenever you put, suppose you have put water in a vessel and you are giving heat to it. So obviously what will happen? It will obviously be getting heat and it will converting itself to gaseous form. But suppose we are simply trying to keep that water in the vessel and letting it like we are keeping that vessel for another one day. Next day in the morning you saw that there is no such water in that vessel anymore. How? You did not have put any extra energy or extra effort to throw it somewhere. No. How is it happening? It is again because of the evaporation. Have you noticed that during the summertime or whenever it is a full sunny day, we wash our clothes and try to put it under the sun to get it dried up? Why? It is just because of the evaporation. Okay? These clothes, these wet clothes, try to absorb the heat of the sun, take the energy from the sun, and it gets converted to a dried material. Okay? So what is evaporation? Sometimes you might also have noticed that you have dropped water on the floor. You did not wipe it, but after some time you saw it is not there anymore. Why? That is again, did you put any burner over there to get it warmed up? No, but it has went off. Why? It is again that because of evaporation. Boiling takes place at a particular temp, that is it needs a particular energy to get converted. Okay, that to get the liquid converted to the gaseous form. But for evaporation, it actually happens at any room temperature. Okay, then another difference of boiling and evaporation. Boiling is very fast. You put the gas on, you put the vessel with the water, and you will see that after some time, after maybe half an hour or something, the full gas, this water has gone off and it has converted to vapor form. But in case of evaporation, it might take a long duration of time. Like the wet clothes getting dried up under the sun. It takes maybe 3 to 4 hours. So it is a slow process. Evaporation is a slow process, whereas boiling is a fast process. Now, you will see that whenever evaporation, you have kept the water on a vessel and you have kept it, you will see the slowly it is getting, the level of the water is getting reduced. Why? Because it is the upper layer of the water molecules that is getting dried up. Slowly it happens. Okay? So it is only concerned with the upper layers of the water. Okay? That is, it is a surface phenomenon. Whereas for boiling, the whole liquid is getting warmed up. So it takes place, that is, this boiling takes up with throughout the liquid. It is not only with the upper level. It is from the side, from the inner portion, from every side. Okay. So these are the main points. And another point I should not forget to tell you, evaporation is obviously bringing a cool effect. Why? I'll tell you that. Suppose in case of you're having fever, doctors or mothers, have you seen our parents do something with us? That is, they put on wet clothes over our forehead, so that what happens is it will take out the heat from our body and our body will come back to its normal temperature. Okay, why is it so? Because these clothes are already wet, right, in cold water. It will take the heat from the body and make our body colder. So that is the phenomenon, that is, it produces a cooling effect. Okay, so evaporation produces a cooling effect, whereas for boiling, the temperature of the surrounding does not changes. But for evaporation, obviously it does. Okay, so this again we will discuss in the physics class also, never mind. And if you're having any problem till here, this was the first chapter. I have completed the chapter of chemistry of class 8. So I don't think you will be having problem. If you're having anything to ask more about something, please do comment. And yes, at last, if you have liked this class, please like, share and subscribe. Have a nice day. Thank you.